Today I'm going to talk about LeetCode question number 105, construct a binary tree from preorder and inorder traversal. Given two integer arrays, preorder and inorder, where preorder is a preorder traversal of a binary tree and inorder is an inorder traversal of the same tree, construct and return a binary tree. So remember, preorder means we visit the parent node first, then the left subchild, then the right subchild, and inorder means we visit the left subchild first, then the parent, then right. Okay, so given these two lists, we need to be able to construct this same tree here. Okay, so let's see if we can find some patterns here. So here's pre 3, 9, 20, 15, 7. And here's inorder, which is 9, 3, 15, 20, and 7. Okay. So now, how can we determine, let's say, how can we determine the root node? Well, according to preorder traversal, we visit the node, then its children, okay? So obviously the first node here will be the first node in our tree, okay? Sure, easy enough. And then, what do? How do you figure out the left children and the right children? So we see an inorder array, we have the 3 here, okay, at this position. And for inorder, remember, it means visit the left children, then the node, then the right children. So obviously, for here, if we have 3 here, obviously means everything to the left are the left subchildren, and everything to the right are the right subchildren. Okay, and we're going to do this recursively, so basically we shrink the preorder and inorder arrays every time. So basically 3's left would be this array here and this array here, and 3's right would be this array here and this array here. Okay, but how do we know what to cut by? How to cut these arrays, especially for inorder, cutting the array is easy enough. We find the element and then we get everything before the element and everything after the element for left and right recursive calls. But for preorder, how do we cut the arrays such that we have this guy for the left recursive call and this guy for right recursive call? So we can actually use the index here, I'll call it I, to be able to cut this array here. How? Well, notice the number of elements to the left of I and the number of elements to the right of I. This basically means everything to the left of I, the number of elements to the left of I will be in the left subtree. Therefore, in the preorder traversal, let's call the number of elements n. So in the preorder traversal, we look n elements ahead of 3, okay, which is 1 in this case, and then this is how we cut. Okay, and for the right side, we notice we have 3 elements here, so we want to, so everything after I, okay, so 0, 1, in this case I is equal to 1, okay. So to the left, we need 1 element, and to the right we need 3 elements. And for a pre-order array, so that means we want to cut by 1 element and 3 elements. So for this guy, since we know the first node will always be the root node or whatever subtree we're looking at, we have to look 1 after, and we have to look I elements after, okay? So for example, if we had like, I don't know, 8 here, and therefore I would equal to 2, that means we have to look 2 elements forward, okay? And this would be 0, 1, and 2. Okay? So it's basically the same as I here. Okay? So that's how we're going to do that. And yeah, since we're going basically up from 1 up to, I inclusive, how we for the left subtree to determine the right subtree, it actually becomes to determine the pre-order array of the right subtree. It becomes simple. It becomes I plus 1 all the way to the end. Okay. And yeah, that's pretty much how we're gonna go about it. So this would be O of n squared solution. N squared because we have to look at each node once, and also in order to search for the index of the current node we're looking at in the Inorder array, we have to traverse through the array. That'll take O of n time. So yeah, it'll be O of n squared runtime. Now to code this up, so basically we're going to define our recursive helper function. Okay, and it's going to take in the pre-order array and the in-order array. And our base cases are going to be if the length of pre-order equals 0 or the length of in-order equals 0, then we're going to in-order equals 0. Then we're going to return none. Okay. Remember, we're cutting the arrays each time we recursively call. So eventually they're going to be of length 0. And when that happens, that means the left and the right values for that node would be none. Okay, so we're going to return none. And then we're going to create a node here based on pre-order of the first element here. Okay, like here. And then index, and then we're going to iterate through the in-order array. Oops. If in order I is equal to pre-order 0, then index is I, and break. Okay, so now that we have within the in-order array the position of our current node, what we're going to do now is recursively call helper node.left is going to be equal to helper pre-order in order. So in order is going to be pretty easy. It's all the way up to index index plus 1, because in Python when you do this, the last part is always non-inclusive, okay? And no dot. I'm going to come back to this later. And no dot right is equal to next plus 1 all the way to the end. So if we have a 1 as our index here, so for left array we want to this guy, and then for right array we want this guy. Okay. Now what about preorder? How do we cut this array? So basically we have index here, which is 1, and what we want to do now is get everything after the first element here of length, this side of the array. So 1 all the way to, and it's gonna be index plus 1, okay? Because 0, 1, this basically says that behind it there is one more element if we're at position 1 here. And now here we want I elements, index of 1, okay? 1 element. So starting from 1, we want 1 element, which is index plus 1. So, and remember, we have to add this plus 1 here because in Python this last part is non-inclusive. So basically we're asking 1 to 1. Basically we're saying if index is 1, we're asking for 1 to 2, but in Python this 2 is non-inclusive, so basically it's 1. It's from position 1 all the way to position 1. Okay, and over here we're basically want so if this is 1, we want index plus 1 all the way to the end. Okay, because we got the first n elements, the number of elements in the left subtree here, and now we want everything in the after the right subtree. So after we got everything in the left subtree, we want everything after the right subtree, and so basically everything after index. And then finally return node. Okay, and then I'll call return helper preorder Inorder. Okay, try running it. No attribute. Oh, forgot to actually create the object. Okay. Okay, looks good. I'll try submitting. Okay, great. Thanks for watching.